In this video, we are going to discuss about how to simulate a DC motor for a different loading conditions using Simulink software. In order to conduct the simulation of brake test on a DC shunt motor, the following components are required. First, DC machine, next DC voltage source, power GUI, scope, display unit, summer unit, step input, bus selector and gain. This is the simulation model for a DC motor in order to conduct a brake test. In this Simulink model, we have utilized various step input at various instant of time. Namely, t is equal to 0 seconds, we will be having the no load torque. T is equal to 3 seconds, we will be having the full load torque. T is equal to 5 seconds, we will be having the half load torque, and T is equal to 10 seconds, we will be having 1/4 of the load torque. And we have used a display units in order to display the armature current parameter, the motor output torque as well as the speed of the DC motor. Now we will try to see how to simulate a DC motor. So initially, with the help of a Simulink, we have to create a new block. So under the new block, with the help of the library browser, you have to choose the necessary elements or functional block that is required for our design. So first is DC machines. So under a DC machine, so this is a DC machine we have picked and placed on a work area. Next we are going to have a DC voltage source. So this voltage source is used as a two different voltage source, one for armature winding and another one is for the field winding. So here we are using a separately excited DC motor. Next we are going to have the step input. So this step input is being used as a load torque input for the DC motor. Next we are going to have the bus selector. So this bus selector is used in order to collect all the output from the DC motor. Next we are going to have a gain unit. So the purpose of this gain unit is to convert the speed of a DC motor in radians per second to RPM. Next we are going to have a power GUI unit. And next we are going to have the display unit. And finally we will be having a summing point. So these are all the basic component that is required for conducting the simulation of a DC brake test on a DC motor. So now we are supposed to fix the specification of the DC motor. So we have nearly 15 different models of DC motor are available in the library, in which I am going to choose a 5 HP 240 volt 1750 rpm and field current of 300 volt rating of a motor. So select, apply and OK. Next we are going to give the basic input to the motor. So we have a single voltage source. So one voltage source is used for DC, armature winding, and another one is used for the field winding. So as per the model that we have chosen, the field winding should be given an input voltage of 300 volt, whereas the armature has to be given an input voltage of 240 volt. So by double clicking on the voltage source, we can vary the input voltage that is being given for the field as well as to the armature. So next we are going to give the load torque to the DC motor. So we are planned to give 4 different variable loads. One at no load condition, another one is full load condition, and next one is half of the full load, and next one is the 1/4 of the full load condition. So these elements have to be connected to the summing point. So since we are having the 4 different load torque, the summation point has to be edited like this. So we will be having a plus plus and minus minus. Apply. OK. So we will connect it off like this. So first torque is a no load condition. Second, we are connecting with the full load condition. Third one is half load, and final is nothing but the 1/4 of the loading condition. Okay. So this power GUI should be placed somewhere in our worksheet. Now we are going to connect the bus selector with the output of the DC motor. So this bus selector is used to connect all the basic output of a DC machine. So if you double click on the bus selector, it will show you what are the basic parameters that is available at the output. So usually we will be getting speed in radians per second, armature current, field current and electrical torque. So in order to we are actually conducting the brake test, so it is enough to have our speed value, armature current value and the motor torque value. So apply. OK. So next one, we have to connect the scope. just a minute. So since it is not connected, so we have issue. So now we have to take a scope from the library. So this scope is used to display all the output of the motor. So since we are need to display three parameters, we have to fix the axis as or layout as 3. Apply. Okay. So connect all the output accordingly. So we are connecting the speed. Next we are connecting the armature current. Next we are connecting the electrical torque. Okay. So usually the output of the speed is nothing but the radians per second, but we will try to have, or we will try to convert that radians per second into a RPM value by using the formula 60 divided by 2 into pi. Apply. Okay. Next we will try to have a display for the all the three parameters individually. So we will connect the first display to the speed, second display to the armature current, and third display to the torque value. So now we have connected the DC motor with the various step input. So in our, now we are supposed to fix the load torque value for the motor different instant of time. So how to fix the load torque value is, we have to fix the load torque by using these formulas. So usually we have three different types of torque. One is the gross mechanical torque. Next one is lost torque, which is due to frictional loss, windage loss and iron loss, and followed by the shaft torque or load torque. The gross mechanical torque will be equal to the summation of the shaft torque and the total lost torque. And we know the output can be calculated by using the formula P out is equal to shaft torque into omega, where omega is equal to 2 pi n divided by 60, whose unit is radians per second. And the output here you have the mechanic, we have represented the output as 5 horsepower. So in order to convert the horsepower into kilowatts, we are supposed to multiply it by 746 as a value. So the output will be converted in terms of watts. So in order to have a full load torque, we use the formula P out by omega, which is equal to 20.36 Newton meter. And next for the half load, it is TL by 2, whose value is 10.18 Newton meter, and for 1 by 4th of the full load, it is nothing but 5.09 Newton meter. So we are going to apply all these values at different time instant. So initially the step input, we are taking it as step input at the instant of time will be equal to 0, whose final value will be 3 seconds. 3 seconds. Apply. Okay. Next, the value of the torque is 20.36 at the time instant of 5. Apply. Okay. Next, we are going to fix as a half the full load torque, which is nothing but 10.18, and the time instant is 10 seconds. Apply. Okay, and next time instant is at the half 1/4 of the full load torque, which is equal to 5.09 at the time instant of 15 seconds. Apply. Okay, so now we have fixed all the load torque values, and now it is we are going to simulate by clicking on the run button. It is simulating. We can view the output in the scope. So the display shows the value of the speed, the armature current, and the electrical torque, and accordingly we can also view the waveform. So in the waveform we can easily observe that there is a increase in the speed value when there is a changes in the load torque is taking place. Similarly, we can also simulate the different DC motors with using a fixed load, or we can use it a variable load. Thank you.